going to discuss about the classes of compounds with functional groups containing heteroatoms. So if I explain about this topic, we have to discuss about some types of compounds within these organic lessons. So I'm going to summarize those topics within the video today, right? They have some functional groups. I will define that term later. Containing heteroatoms mean they have different types of atoms. Homoatomic mean just one type, like Cl2. The two atoms are chlorine. But in heteroatoms mean different types of atoms are present within that molecule. First of all, we will know what a functional group is. Group of atoms in a molecule where most of its reactions take place is known as a functional group. We call functional group that in that part of the compound the reactions take place, most of the reactions take place in that group, so it is a functional group. But alkenes, alkynes, ethers and alkyl halides, they are not considered as functional groups in IUPAC nomenclature system. So you should remember that alkenes, alkynes, ethers and alkyl halides are not considered as functional groups. Type of compound that we should discuss is alcohol. We have discussed about alkene, alkane and alkynes previously, so I'm not going to discuss about them here. Except them, we will start from alcohol. So if we take a hydrocarbon and replace its hydrogen atom, one of the hydrogen atom, with OH group, so then we consider it to be an alcohol. So here this is methane, right? This is methane. I am going to replace one hydrogen atom of this methane with OH. Then here you can see an alcohol, that is methanol. One carbon is there, due to that meth. Alcohol, we use OL suffix in alcohol, so this is methanol, right? So if we take an alkane and replace one of its hydrogen atom with a OH group, then it is an alcohol. You should compulsorily take alkane, right? We cannot take an alkyne or alkene and replace hydrogen atom, and that is not an alcohol. We should take an alkane and replace one of its hydrogen atom with an OH group, so then it is an alcohol. We will discuss about the nomenclatures of these in another video. Till then, just remember, just try to identify a given compound as alcohol, ether, amine, amide. Like, you should be able to identify what it is. So it will be important in our conversions, right? I will teach you the nomenclatures of these in another video, right? Till then, you should be able to identify a given compound. To which type does it belong? You should be able to identify it after this video. That is my purpose of this video, not the nomenclature. I will teach you it in another video, right? Okay. Then the second type is ethers, right? So compounds containing an oxygen atom attached to two alkyl groups is an ether. So if we take an oxygen atom and two R groups are attached to it, when two R groups are attached to it, this is an ether. You know what R group is, right? If we take an alkene and replace one of its hydrogen atom, then it will be an R group, or we call it alkyl group. So here this is methane. If I remove this hydrogen atom from this becomes CH3. CH3 is positively charged, so carbon cannot exist like that, so we consider it as a group which binds to another atom or a group, right? So here one carbon is there, so we can call it methyl. Methyl, right? If we remove one hydrogen atom from an alkane, so that is an alkyl group, and it is represented by the letter R. So when two alkyl groups are attached to oxygen, then that is ether. Then aldehyde. Compounds containing a carbonyl group attached to a hydrogen atom is known as aldehyde. Right? So here if we consider carbon double bonded to oxygen is a carbonyl group, right? To a hydrogen atom, if there is a carbonyl group attached, we called it aldehyde. So here hydrogen atom is there. For that, a carbonyl group can be attached like this. So another bond can be formed by carbon. It can be a R group, a hydrogen atom, or like that. If hydrogen is bonded to a carbonyl group, that is C double bonded to oxygen, then that is an aldehyde. Carbonyl group is attached to two carbon atoms belonging to alkyl or aryl group. I have said you what alkyl group is. Aryl group mean if we consider a carbon ring like this, we will discuss this in detail in benzene, right? This is benzene. Here this is benzene. From this benzene, if we removed a hydrogen atom, then this is aryl group. Then this is aryl group. So, in these terminals, there are carbon atoms. Here you can see 6 carbon atoms are there in benzene. For a carbon atom of this aryl group or alkyl group, one carboxyl group is attached to two of these, two carbon atoms, then that is a ketone. Then that is a ketone, right? Here you can see this is a carbonyl group and it is attached to two carbon atoms of two alkyl groups. Alkyl groups. Here these are two of alkyl groups. And in this situation, this is a carbonyl group. It is attached to a alkyl group and also to a aryl group. One carbonyl group should be attached to two carbon atoms belonging to aryl group or alkyl group is known as ketone. Then we will discuss about alkyl halides. Compounds containing a halogen atom bonded to an alkyl group is known as alkyl halide. So you know what alkyl group is. So if we join an alkyl group with a halogen atom, then it is a alkyl halide, right? An alkyl halide. So here in this case we can do it in another way. I will explain you it in another way, right? Here hydrogen atoms are there. If I replace one of these hydrogen, if I replace one of this hydrogen with a halogen atom, chlorine, fluorine, bromine, iodine, like one of the halogen atom in group 17, then that is an alkyl halide. It's a different way of explanation, right? So if we remove a hydrogen atom, this becomes an alkyl group. Then we should attach a halogen atom here, then it is an alkyl halide. So here in this side you can see, a compound written. So it is easy for us, without drawing the lines, to write a compound in this way. If I expanded this one, that is like this. C carbon is there, 3 hydrogen are attached to it, and then for that another carbon is attached, and for that carbon 2 hydrogen are attached, and for it a bromine atom is attached. Here this is written as CH3, this is written as CH2, and here this is the bromine. So that is an easy way of writing the compounds, hydrocarbons. Carboxylic acids. Compounds containing the carboxylic acid group is known as carboxylic acids. So here this is a carboxylic acid group. Carbon double bonded to oxygen and single bonded to OH group. Then that is a carboxylic group. Right? So if a carboxylic group is attached to a aryl group, this is an aryl group, or alkyl group, here this is an alkyl group, then we call that compound as carboxylic acid. Right? Here you can see carboxylic acid group, and here this is aryl group, this is alkyl group. If a carboxylic acid is bonded to a aryl group or alkyl group, then that is a carboxylic acid. Going to discuss about some derivatives of carboxylic acids. Acid halides, esters, amides, these three are derivatives of carboxylic acids, right? So we said that a carboxyl group is a carbon atom attached to oxygen atom through double bonds and OH group through a single bond, right? So in this case, if this OH group is replaced by a halogen atom, then it is acid halide. If that halogen atom is a chlorine atom, then that is acid chloride. If it is bromine, acid bromide, like that, right? So here carbon atom is bounded to a double bond oxygen, replacing the OH group. Replacing this, there should be chlorine, bromine, iodine, or fluorine. So we say it carboxylic acid chloride, acid bromide, acid fluoride, acid iodide, like that, right? So here we can give a common structure like this: oxygen double bonded to carbon, a halogen single bonded to a halogen, and here alkyl or aryl group, right? So here like that we can give the common structure. I think you could understand that acid halides are the compounds containing COX group, where X is a halogen atom, right? Okay. The other derivative of this then the other derivative of carboxylic acid is ester. Compounds containing COOR group is an ester. That means a carbon atom should join to an oxygen atom through double bonds, and replacing the other two bonds there should be OR group and here arylo alkyl group, right? Like this. Carbon should be bonded to an oxygen atom through a double bond, and by a single bond that carbon atom should bound to a OR group, and to the other side there can be a aryl group or alkyl group. So we will elaborate this here. This is carbon bonded to oxygen through a double bond, and here this is OR, and here is the R group. So this is an ester molecule. So compounds containing CONH2 group is amide, right? So here if a carbon atom is double bonded to oxygen and amino group in the side and R group in the other side, then it is an amide, right? So here carbon should have 4 bonds. 2 bonds are with oxygen, 1 bond is with amine group, and the other one is R group. So that is an amide. You can simply understand that structure. In these bends, carbon are represented. In organic chemistry, we do not generally write that as carbon because it indicates the existence of carbon atoms. We will discuss about amines. Compounds derived by replacing hydrogen atoms of ammonia by alkyl or aryl groups are known as amines. So here ammonia means NH3. There are 3 hydrogen atoms for this ammonia, like this. So we can replace either one of this hydrogen or 2 or even 3 hydrogen atoms with alkyl or aryl groups. So then it becomes an amine. Here this in the given compound 2 hydrogen atoms are replaced by 2 alkyl groups. We can even replace 3 hydrogen atoms. The last compound is nitrile. Compounds having molecular structure in which a cyano group is attached to a carbon atom, then it is a nitrile. Cyano group means carbon bonded to nitrogen with 3 bonds, triple bonds, right? So carbon can have 4 bonds, 3 bonds are with nitrogen, and as the other bond there can be a bond with alkyl or aryl groups. So here it is given the common structure. If carbon is bounded to a nitrogen with 3 bonds and aryl or alkyl group is bound as the other bond, then that is a nitrile. At the end of this video, you should be able to identify a given compound. So you should be able to describe to which group the given compound belongs. So to practice this one, I am going to put you some activities to my Telegram channel. So I request you all to subscribe that and be with that to practice the theory that we discussed here. So my purpose of this video is to make you able to understand, to identify the type of compound, type of organic compound given. So thank you for being with me till the end. Subscribe and like the video. if you had some use with it.